I'm Savannah Brandon, and we are going to go through some thin layer chromatography.
Step 1, developing your chamber. So for the chamber, it's the solution, the developing solution is 2 milliliters of ethyl acetate and 8 milliliters of heptane. And what you want to do is put your filter paper along the wall of the jar, and with your solution, you're going to want to go like this to make sure that it's on the filter paper, and that's so that it ensures that the air in the chamber is saturated with the developing solution. You got to keep the cap on to prevent evaporation.
Silicone aluminum plates, and we are marking the plates now. And we're going a centimeter up from the bottom and doing a thin line to make sure to not damage the plate.
So Savannah is putting little tick marks so we can keep track of where we put our dots originally. You want to do this in pencil because if you were to do it in pen, it would dissolve with the dissolving solvent and it would just mess up our whole results. So you have to check your capillary tubes to make sure there's no jagged edges and that it's not broken. Now I'm going to take, this is fluorine, and I'm gonna dip my capillary tube in to the liquid, and there we go. Cover that back up. Okay, and I'm gonna put it one small drop right here, and I need to let it dry. And you want a small dot around 1 to 2 millimeters in diameter. So that one's drying. I can go one more time, and that should be good for the fluorine.
So first you check your capillary tube to make sure it isn't frayed or fragmented so it will work properly. Then you take your fluorine and draw up a little bit. Okay. Then you close your tube.
Okay.
Yep. There it goes. Our second drop. These tweezers. We're going to place the paper vertically in the jar on this side. And we're not going to move the jar because it will disrupt the molecules.
And then you're going to want to take the filter paper out of the jar when it gets to about, the solution reaches about 5 milliliters to the end of the top of the paper. So now we're going to take it out with the tweezers. And you see, you want the level of saturation not up to the edge, but to right there. And we're gonna mark that layer right now with the pencil, and it'll help us with our RF calculations.
Okay,
So now,
we waited till they dried, and now we're looking at them under the UV light.
actually, bring the camera up here. So now, in pencil, we're gonna circle where the dots are.
Very lightly. Oh, sorry, I think I bumped you.
Okay.
Okay.
Now we're gonna take them out and measure the distance from the starting point to our solvent front, and then the starting point to the center of the dot.
Do you want this?
Yeah. So
Okay.
So from our starting point to our solvent front, it is 3.7 centimeters. Meters is our distance B, which is from our starting point to our solvent front. And for the fluorone, the distance is 1.5 centimeters, which is distance A. Now let's do for fluorine. Distance A is going to be 2.4 centimeters.
Thumbs up.
Savannah is now doing the RF calculations. And what you want to do is you're going to take your A measurement over your B measurement. And the range that you want is between 0.2 and 0.8. As you can see, we are within range for our fluorine at 0.65. And then for our fluorinone is 0.41.
Okay.
That was for our first
Sheet. This value is dependent on the polarity of the compound, and if it is a more polar solvent, it'll have a higher RF. So fluorine is more polar than fluorinone, based on our experiment.
for our second sheet that we did, which was this one. You can see in comparison that the solvent front is a lot higher than the first one's solvent front. But the calculations still fall in within the range of the 0.2 to the 0.8, and fluorine is still more polar than fluorinone.